Let's now focus on scale rounding mode only on its own. Here again we are looking into MXFP4 number format where the scale format is E8M0, a power of 2 format, and element format is E2M1. For element format, element rounding, we are using RTNE on both sides. But for the scale, we are using two different rounding format. One is floor, one is ceiling. And these two will be used on how we round the scale. As usual, I have the running example of 0.3, 0.8, 1.2, 2.1, 7.2. The way you calculate the scale is you take the max of your input and then you take a log base 2 of that, then you subtract the bias. And then comes the question, should we take a floor of that or should we take a ceiling of that? So on the left, we are taking a floor and then we are raising power of 2 to that or to the power of that, and that gets you scale of 1. On the right, we are doing a ceiling, and then we are raising the power of 2. That gets you scale up 2. Now let's take a look at the intermediate. So when look at all the intermediate value for scale 1, they get normalized to the same value, 0.3, 0.8, and so on, 7.2. And then when you map them to legal E2M1 elements using RTNE, what you see is that all these values, they get mapped to separate buckets, but the maximum value, 7.2, gets clamped to 6, which is the maximum possible value in E2M1. 2.1 gets mapped to 2, 1.2 and 0.8 both get mapped to 1, 0.3 gets mapped to 0.5. If you calculate the total block mean square error for this distribution is 0.3140. Okay, this is quite high compared to on your right, which is 0.1640. Why is that? Here, because we took ceiling on this log 2 of 7.2 minus the bias, I got a scale which is of 2, and when I normalize all this number, all those numbers get halved. So 0.3 gets become 0.15, zero point 0.8 gets zero point 0.4, and the max gets halved to 3.6. Now 3.6, so when you take these numbers, normalized number, and you try to map to legalized or legal E2M1 values, element values, your max gets mapped nicely to 4. There is no clipping. All the other values correspondingly get mapped to 0.5 and 1. But there is another effect here, is that the lowest value, 0.15, gets mapped to 0, meaning there is an underflow. Although your block MSC is smaller, on both rounding scheme, there is some effect. On floor, in this particular value of max, you have a clamping or overflow. And in the ceiling, you have an underflow where you have a clipping on this side, on the lower side underflow, which is 0.00. Right? So let's try to understand this contrast. It would be an interesting experiment to understand what happens for different value of max. Now remember that E8M0 scale has a power of 2 scale. Because of that, you have very legal values like 1, 2, 4, 8, and so on. So here, to kind of give you the effect of different max values, I'm sweeping from 4 to 8. That's one of the range of legal values E8M0. And this effect will repeat in every range. So let's take a look at 4 to 8. If you look at, I divide it into three main regions: a green region, a yellow region, and a blue region. Let's take a look at the green region. In the green region, if you look at, you see there is no clamping. The higher value, the max value, gets very nicely mapped to 6. But on the right side, on the ceiling, you see there is an underflow. The lowest value gets underflow, and there's a truncation, and that becomes 0. On the blue region, on the other hand, you see there is a clamping on the floor scheme. So 7.4 becomes 6, and you have a clamping, and you have a very high error on the floor. And on the right side on the ceiling, you have a underflow, 0. But your block MSC is still reasonable compared to the left, the floor scheme. The yellow region is very, very interesting. So if I come to this region, you can have a scenario like this where you have a clamping on the floor and you have an underflow on the right on the ceiling, but your total net mean square error is very high on the ceiling. So you can see that there are multiple scenarios. Wouldn't it be nice if I could pick and choose the rounding scheme given my distribution? So let's try to answer that question next.